Hello everyone, I'm Xiao Gang. Okay, in this chapter, we will continue to talk about WebSocket and we will talk about speech synthesis because it is quite important and it involves things. Now you have speech recognition and we have also explained the large model. Then we will talk about speech synthesis. In fact, your digital human framework is complete. So we decided to add another chapter to explain speech synthesis. Let's first look at the effect. This is the project we tested before. Let's use this one. It should be this: study hard, make progress every day. Okay, everyone should be able to hear this effect. Can hear this effect? Yes. I'll mute my microphone here. Then let's listen again. Study hard, make progress every day. Okay, so this is the speech recognition effect. Then let's see how we call it in Blueprint. It is called through this Blueprint variable node. And it's actually the same. We pass in our API IDK secret. Then we pass in the text we want to synthesize. Then there is a boolean here that determines whether we want to generate it as a local WAV file. Then we just need to pass a part. As for these request parameters, there's not much to say. That is the speech speed, or tone, or pronunciation standard for the speaker. There's not much to say about this. Then these voices. This is the most basic free voice. The quality is definitely average. But everyone mainly just needs to run through the process. Then after success, if we can get the U class, then play it. If you want a local file, it will also perform local read and write on the local file. Basically, that's how you call it. Now let's talk about what's special about it. When you write a local WAV file here, it actually needs to be written asynchronously. Why does it need to be written asynchronously? Because when you read and write files, it is actually very resource intensive, so you need to write it asynchronously. This is quite special. Then we dynamically generate the USoundWave object, and in the previous slide I explained the code for this part. It is not usable in versions 5.43 and 5.44 because I tested it. This is related to the engine's version update, and it works fine in version 5.4.2. We don't have time to iterate on this part, so let's just leave it for now. The issue of USoundWave not playing in the latest version. We'll fix this issue later when we have time. Just fix it, and it will be fine. And it definitely works normally in version 5.3. In versions 5.3, 5.2, and 5.1, there are no issues. So then, that is to say, how do we write this WAV file? Anyway, this is much simpler than our previous chapter because it won't involve so many audio generation threads, audio consumption threads. But if you want to write it in, you can make it that complex. And this interface can also be iteratively optimized because some lip sync plugins, some of them are driven by PCM and some use WA files. So we recommend that everyone use WA files. We haven't provided customized data for you here. If you need to use it later, you can extend it yourself. We just save it directly to the local storage because it's convenient for us to manage and use. And then as for the interface here, let us show you which interface this is. The interface here is this one, and it uses the wedge quad method. There are some pitfalls here. We'll explain them to you later, then you'll understand. Yes, okay, then we'll explain to you these details. This is the WA file. Actually, there are two ways to write it. We can write WA ourselves, or we can write it by calling the engine's method, including this USound, the external PTR engine. The methods it provides are no longer usable either. This is caused by the update. Let's just ignore it for now. Okay, that's all for this lesson. Let me show you the sample. After we write this out, the effect will look like this. Okay, thank you everyone.